All right, finally one that's worthy of your, genius here. Right? So, and this is what they look like. We'll find the voltage at this origin right here, which is of course right there, I assume, right? Okay, it's like, I need a space to work in. All right, so the voltage at this point, right, due to A is equal to, let's see, A is negative, right? So it's going to be 8.99 E9 times negative 14.7 E minus 6 divided by, and then A is 1, 2, 3, 4 over 1 down, right? 4 squared plus 1 squared. So what is that? E9 times 14.7. 6, whoops, I forgot the minus sign. You don't want to ignore the minus sign on these, okay. And then that's divided by the square root of, what is it, 4 squared? This is equal to negative 32,000 volts, right? Negative because of the negative there, right? And then the voltage due to B at the origin is 8.99 E9 times 17. Two over, okay, so let's see. 2 over 2, so 2 squared plus 2 squared. All right. So we're going to plug that in. Let's see. 8.99 E9 times 17.2 E minus 6 divided by the square root of 2 squared plus 2 squared. That is positive 54,669.3 roughly volts. And then, of course, we're just going to add those, right? The voltage at the origin equals the voltage due to A plus the voltage due to B. So we'll go minus 32,051.8 plus 54,669.3. What is that going to be? That plus this is 22,617.4 volts. Ta-da. I guess we had 3 sig figs. There's the answer. I guess we got it right. Is that to the fourth? 1, 2, 3, 4. Yes, it is.